In this video, I'm going to explain about the MPLS traffic engineering dynamic path tunnel. Here again, we have 5 routers. And as you can see in this scenario, we have 3 paths between the router 1 and router 5. The blue path, the red path, and also the green path. The bandwidth of the blue path is better than the bandwidth of the green and red path. Because of that, IGP, for example, OSPF in this scenario chooses the blue path as the best path between the router 1 and router 5. We can see it. Only you need to use show IP route in router 1. And as you can see here, for example, to reach to quad 5/32 or 5.5.5.50/32 or the 192.168.2545 /32, all of them are reachable from the gigabit 00, means blue path. Assume that we want to use the bandwidth of all links. Without traffic engineering, only you will use one of these links, for example, the blue path. Okay, how we can share traffic dynamically between the 3 paths? For example, assume that we have some traffic with requirement of 9 megabit per second of bandwidth and some other 5 megabit per second of bandwidth and some other 2 megabit per second of bandwidth. With traffic engineering, you can send the first traffic, means 9 megabit requirement bandwidth from the blue path, the second type of traffic or flow with 5 megabit per second of bandwidth from the red path, and the third flow from the green path with 2 megabit per second of bandwidth. Actually, you can define the tunnels with the requirements that you have, and automatically traffic will be sent from the path that can actually provide us the requirement of traffic, for example, bandwidth. Okay, let me to show you how we can configure dynamic path tunnel. What is the goal of this scenario? The goal of this scenario is to define tunnels, and after that, in that tunnel we want, or those tunnels, we want to configure the requirement related to the bandwidth. And we expect to see that traffic engineering or MPLS traffic engineering dynamically will find the path with the requirement of our traffic. It's very interesting feature. You know that in previous video, we have learned about the explicit path tunnel. Now we don't configure any explicit path. We only define the requirement of our traffic. And this is the function of MPLS traffic engineering that will find the path with our requirement. Let me to show you. This is our text file. Again, we have some steps in this text file. Step 0 is IP address configuration and then enabling interfaces on router 1 to router 5. Step 0 also includes the IGP configuration, here again OSPF, on R1 to R5. I configured all of these steps previously, and you have this configuration. For example, in router 1, as you can see, I configured on gigabit 00 bandwidth 10,000, means 10 megabit per second or 10,000 kilobit per second. On gigabit 01, the bandwidth is 6,000 kilobit per second or 6 megabit per second. And on gigabit 02, the bandwidth is 3000 kilobit per second or 3 megabit per second. Step 0 is done, and you have this configuration. You can use it. Let me go to step 1. What is the step 1? Step 1 is global MPLS traffic engineering TE configuration in R1 to R5. I explained it before in previous video, but you know that we need to ensure that IPsec is enabled, and the good news is that IPsec by default is enabled. We need to define or configure MPLS traffic engineering tunnels in all of our scenarios. This is by default disabled. And then if you want, and also it is recommended to use MPLS label range between two values, that it can help you to better understand, to troubleshoot the MPLS features like MPLS traffic engineering. For example, MPLS label range 100 to 199 in router 1. Let me to configure step 1. This is actually here we don't have any new node. In the router 1, again MPLS traffic engineering tunnels, and then MPLS label range 100 to 199. That's it. Then router 2 again, configure terminal, and after that MPLS traffic engineering tunnels, MPLS label range between 200 to 199. Router 3, again MPLS traffic engineering tunnels and MPLS label range 300 399. Router 4, configure terminal, MPLS traffic engineering tunnels, MPLS label range 400 499. Finally, router 5, again MPLS traffic engineering tunnels and MPLS label range 500 599. This is the step 1, and you have this configuration. What is the step 2? Step 2 also is similar to the previous video, explicit path tunnel. We need to enable traffic engineering on the OSPF with these commands: MPLS traffic engineering area ID and MPLS traffic engineering router ID loopback ID. I explained these two commands previously. Because of that, only I'm going to show you how you can configure it. Router OSPF 1, MPLS traffic engineering area quad 0, and MPLS traffic engineering router ID loopback 0. You can copy these commands on all routers. This is not new for us. Because of that, I will copy these commands on router 1, and then router 2, and then router 3, and router 4, and finally router 5. Actually, we enabled IGP for traffic engineering, and we define the router ID of each routers. Let me go to step 3. Step 2 is done, and step 3 needs to configure traffic engineering on all interfaces with these commands: MPLS traffic engineering tunnels, and then we need to enable RSVP, IP RSV bandwidth. In previous video, we configured maximum reservable bandwidth, but this is optional. You can configure only IP RSVP bandwidth, means the RSVP can reserve all bandwidth of the interface. Because of that, in router 1, we need to use only interface range gigabit 0022, MPLS traffic engineering tunnels, IP RSVP bandwidth. Let me to copy these commands and then paste it on the R1 CLI. That's it. Also, in router 2 and router 3 and router 4, okay, means these three routers, only we need to copy these commands: MPLS traffic engineering tunnels, IP RSVP bandwidth on gigabit 00 and gigabit 01. Let me to show you. This is the R2's configuration, then R3's configuration, and then R4 configuration. On router 5, we have one more interface, as you can see here, interface gigabit 00 Let me to copy this configuration and paste it on the R5 actually CLI. All right, this is the step 3 that we configured now. Now, we need to go to step 4. In step 4, we need to configure 3 tunnel interfaces on R1 to R5. And tunnel 0's requirement is destination IP, router 5, the tunnel type is dynamic. It means that it should find the path itself, and we don't configure any explicit path. And after that, bandwidth requirement is 7 megabit per second. The only path that can provide us 7 megabit per second of bandwidth is the blue path. But tunnel 1 needs 4 megabit per second. It means that it will choose the red path, because the blue path doesn't have our requirement after reserving 7 megabit per second of bandwidth, and only the red path can provide this amount of bandwidth for us. And the green path requirement or the tunnel 2's requirement is 2 megabit per second, and after the actually reservation, the green pass will provide us this amount of bandwidth. Don't forget, in some versions of iOS, in more recent versions of iOS, only 75% of bandwidth can be used. For example, if you have 10 megabit per second of bandwidth, only 7.5 megabit per second of bandwidth can be reserved. It is possible. Okay, let me to show you in router 1, interface tunnel 0, then IP unnumbered loopback 0. Tunnel destination is 192.168.2545. Tunnel mode is MPLS traffic engineering. Tunnel MPLS traffic engineering bandwidth requirement is, for example, 7,000 for the first tunnel. And after that, tunnel MPLS traffic engineering pass option 1 dynamic. Here we don't use explicit. Okay, we use dynamic. After that, the tunnel 1 requirement is 4,000 kilobit per second, and tunnel 2's requirement is actually 2,000 megabit per second of requirement. Let me to configure this scenario. Here in the router 1, first we need to define the interface tunnel 0, and then IP unnumbered loopback 0. Tunnel is down now, and then tunnel destination is 192.168.2545. Tunnel mode is the MPLS traffic engineering, and tunnel MPLS traffic engineering actually bandwidth requirement is 7,000 kilobit per second. Okay, and then tunnel MPLS traffic engineering pass option 1 dynamic. Now the tunnel will come up because the actually blue pass can provide this amount of bandwidth for tunnel 0. I will show you the result of our configuration, but first let me to define the tunnel 1. Tunnel 1 again has this command IP unnumbered loopback 0. Okay, and then tunnel destination is 192.168.2545, and tunnel mode is the MPLS traffic engineering, and tunnel MPLS traffic engineering bandwidth requirement is 4,000 kilobit per second or 4 megabit per second. And after that, tunnel MPLS traffic engineering, then pass option 1 is dynamic. Okay, and the tunnel will come up after finding the pass, and then the last tunnel, interface tunnel 2, again IP unnumbered loopback 0, and then a tunnel destination is 192.168.2545, and after that tunnel mode is MPLS traffic engineering, and tunnel MPLS traffic engineering bandwidth requirement is 2,000, and finally tunnel MPLS traffic engineering pass option 1 dynamic. And this tunnel also will come up. Okay, let me to show you the result of our configuration. Show MPLS traffic engineering, then tunnels, for example tunnel 0. You know that we didn't define the tunnel 0's pass ourselves. This is the traffic engineering or MPLS traffic engineering that should find the pass with our requirement. Look at here. Here, the name of our tunnel is R1 tunnel 0, and destination is 192.168.2545. Administratively, this tunnel is up, operationally is up, pass is valid, and signaling is connected. Pass option 1 configured as dynamic, as you can see here, and it is automatically choose this pass. Look at here, from router 1, this is the pass that it find from router 1 to router 2, and then to router 5 means blue pass. I didn't define it. It actually find it automatically. So easy. And after that, if you check the tunnel 1, you will see that tunnel 1 now is using the R1 tunnel 1, this pass. Router 3, router 5 means red pass. And in tunnel 2, as you can see here, we have the green pass, means router 4 and router 5. Now, actually, our tunnels, according to our requirement, use different paths. Actually, we can distribute the traffic with these tunnels. For example, in the next step, step 5, we need to configure 3 static routes on R1. To reach to 192.168.2545, please use tunnel 0, means the blue pass. To reach to quad 5/32, please use tunnel 1, means the red pass. And to reach to 5.5.5.50/32, please use tunnel 2, means the green pass. You can define these 3 static routes: IP route to 192.168.2545, quad 255, use tunnel 0, IP route quad 5, quad 255, tunnel 1, IP route 5.5.5.50, quad 255, please use tunnel 2. Don't forget, here again, we are using the static routing to steering traffic into the tunnels, but we have other methods. Let me to configure these 3 tunnels because I want these 3 static routes because I want to show you the result of our configuration with the IP route command in the router 1. I can show you IP route and then 192.168.2545 quad 255, and after that tunnel 0, and then IP route, for example, quad 5 255, okay, 255 255 255, tunnel 1, and IP route 5.5.5.50, quad 255 as the subnet mask, please use tunnel 2. Now do show IP route static can show us that we have 3 static routes, each of them use different tunnel. Also, if you want, you can check trace route to 192.168.2545 numeric can show us that it uses the blue pass. As you can see, label 200 is received from the router 2 and it goes to the router 2 and then router 5, and after that trace route to the quad 5 and then numeric. The traffic went to router 3, then router 5. And finally, 5.5.5.50 traffic went to the router 4 and router 5. What does it mean? The green pass. Also, it's interesting to see the result of show IP RSVP interface. Show IP RSVP interface can show us that gigabit 00 has this amount of actually reservable bandwidth. You know that because here we have 10 megabit per second of bandwidth, as I explained before, 75% of the bandwidth can be reserved, means about 7,500 kilobit per second. Okay, and we allocated 7 megabit because in tunnel 0 we configured at the 7 megabit per second. Because of that, it reserved for us this amount of bandwidth. And on the gigabit 01 we define the actually 6 megabit per second of bandwidth. This is the maximum reservable bandwidth, but because of the limitation of 75% of the link bandwidth, reservable bandwidth, actually here we have only 4,500 kilobit per second of maximum bandwidth, and we used 4 megabit per second. And also in the gigabit 02 we use 2 megabit per second of bandwidth. All right, in this video we learned about the dynamic path tunnel. In previous video we learned about the actually explicit path tunnel. Now we have more knowledge about the different type of tunnels in MPLS traffic engineering, and also we have other method that I will explain it in the next videos. The semi-dynamic tunnel. You know that until now we learned about the explicit path, dynamic path, and we will learn about the semi-dynamic path. But about steering traffic into our traffic engineering tunnels, until now we have used static routing, but we have other methods that you will learn about them in future. Now it's your time. You need to configure this scenario from the scratch. After understanding, you can continue learning about the MPLS traffic engineering and with the next method, semi-dynamic tunnels.